Feedforward Neural Networks. Feedforward Neural Networks. AI beginner means intermediate level. Introduction. Neural networks are the foundation of modern machine learning and deep learning. They allow computers to learn patterns from data and make predictions. Among the many types of neural networks, the Feedforward Neural Network, FNN, is the simplest and most fundamental architecture. Feedforward neural networks are used for tasks such as classification, regression, pattern recognition, anomaly detection, recommendation systems. They are the starting point for understanding more advanced neural network architectures. Learning feedforward neural networks helps build a strong foundation for studying deep learning and artificial intelligence systems. What is a feedforward neural network? A feedforward neural network, FNN, is a type of neural network where information moves in only one direction. Data flows from input layer through hidden layers to the output layer. In simple terms, feedforward neural network equals a neural network where data moves forward from input to output without loops. Example concept. Input layer means hidden layers means output layer. There are no cycles or feedback connections in this network. Why feedforward neural networks are important? Feedforward neural networks are important because they form the basic building block of deep learning. Many advanced neural networks are built upon the same idea. Example concept. Simple neural network means foundation for deep learning models. Understanding FNN helps learners understand neural network layers, weights and biases, activation functions, forward propagation, back propagation. Structure of a feedforward neural network. A feedforward neural network typically contains three types of layers. Input layer. The input layer receives the raw data. Examples of inputs include image pixels, numerical features, sensor readings, text embeddings. Example concept. Dataset means input layer. Each input feature corresponds to a neuron in the input layer. Hidden layers. Hidden layers perform feature extraction and pattern detection. Each neuron processes inputs using weights, biases, and activation functions. Example concept. Input means hidden layers detect patterns means output. Deep neural networks contain multiple hidden layers. Output layer. The output layer produces the final prediction. Examples include class label, probability score, numerical prediction. Example concept. Hidden layers means output prediction. Mathematical representation. Each neuron in a feedforward network performs a weighted calculation. Y equals F. Sum underscore I equals 1, caret, N, W underscore IX underscore I plus B. Where X, I equals input values. W, I equals weights. B equals bias. F equals activation function. Y equals neuron output. This calculation allows the network to learn patterns from data. How feedforward neural networks work. The working process involves forward propagation. Workflow. Input data. Down pointing arrow. Weighted sum calculation. Down pointing arrow. Activation function applied. Down pointing arrow. Output passed to next layer. Down pointing arrow. Final prediction generated. This process continues layer by layer until the output is produced. Training feedforward neural networks. Feedforward neural networks learn through training. Training involves several steps. Input data. Down pointing arrow. Forward propagation. Down pointing arrow. Prediction generated. Down pointing arrow. Loss calculated. Down pointing arrow. Back propagation computes gradients. Down pointing arrow. Weights updated using gradient descent. This process repeats many times until the model improves. Activation functions in FNN. Activation functions introduce nonlinearity into the model. Common activation functions used in feedforward networks include ReLU, sigmoid, tanh, softmax. Example concept. Neuron output means activation function means final signal. These functions allow the network to learn complex patterns. Example feedforward neural network. A simple feedforward network might look like this. Input layer. 3 neurons. Down pointing arrow. Hidden layer. 5 neurons. Down pointing arrow. Hidden layer. 4 neurons. Down pointing arrow. Output layer. 1 neuron. Example concept. Features means pattern detection means prediction. Example Python code. A simple feedforward neural network using TensorFlow. Import TensorFlow as TF. Model equals TF. Keras, sequential. TF, keras, layers, dense. 16. Activation equals ReLU. TF, keras, layers, dense. 8. Activation equals ReLU. TF, keras, layers, dense. 1. This creates a neural network with 2 hidden layers. ReLU activation. 1 output neuron. Applications of feedforward neural networks. Feedforward neural networks are used in many AI tasks. Classification. Identifying categories such as spam versus non-spam emails. Regression. Predicting numerical values such as house prices. Pattern recognition. Recognizing patterns in datasets. Financial forecasting. Predicting market trends. Healthcare. Disease prediction from medical data. Advantages of feedforward neural networks. Feedforward networks provide several benefits. Advantages include simple and easy to understand, foundation for deep learning, efficient for many prediction tasks, flexible architecture design. Example concept. Simple neural network means powerful pattern recognition. Limitations of feedforward neural networks. Despite their usefulness, FNNs have limitations. Limitations include cannot handle sequential data well, do not remember previous inputs, may require large datasets for good performance. Example concept. Sequential data means better handled by RNNs. More advanced architectures solve these limitations. Concepts learned from feedforward neural networks. Understanding feedforward neural networks helps learners understand. Checkmark how neural networks process data. Checkmark how layers interact in deep learning models. Checkmark how predictions are generated. Checkmark how backpropagation trains networks. Checkmark how deep learning architectures are built. Feedforward networks form the foundation of many neural network architectures. Simple definition. Feedforward neural network. A neural network where data flows in one direction from input layer to output layer without loops. Final summary. Feedforward neural networks are the simplest type of neural network architecture. They process data by passing it forward through layers of neurons without feedback loops. Each neuron performs weighted calculations followed by activation functions to generate outputs. These networks are widely used for classification, regression, and pattern recognition tasks. Understanding feedforward neural networks is essential for learning deep learning and modern artificial intelligence systems.